Hello everyone. Today we will be discussing dual nature of radiation and matter and understand de Broglie's wavelength of an electron. Before we jump into the de Broglie's hypothesis, let us look at some basic concepts supporting this topic. The concept of free electrons and work function. In metals, the electrons in the outer shell are loosely bound. They can move freely within the boundary of the substance in random order. You can consider the movement of these electrons similar to the movement of gas particles confined in a space. These electrons cannot leave the confined surface at any cost. Even if they try to leave the surface, the substance itself will become positively charged as a negative electron will escape it and will consume the electron back due to the charge imbalance. Hence, in nature, a substance will never lose its electrons without any external cause. There is a minimum energy required by an electron to just escape the metal surface, which is known as work function. Now, this energy required by an electron to escape the substance should not be confused with the ionization energy, which is learnt in the concept of chemistry. Ionization energy is the energy required by an electron to escape the valence shell of the atom or the molecule it is attached to. And the work function is the energy required by an electron to escape the substance itself. The work function depends mostly on the nature of the metal, and the work function for metal varies as per its physical and chemical properties. The work function is generally denoted by W0 or phi naught, and the unit which is used to measure work function is eV, known as electron volt. Now, 1 electron volt in terms of joule is represented as 1 eV is equal to 1.602 multiplied by 10 raised to minus 19 joules. Below is the work function described for few metals. This chart clearly shows that work function for different metals is different. The phenomenon that work function causes is known as electron emission, in which the electron from a metal surface is escaped. The electron can escape the surface or the substance in different ways. The following are the methods which are used to help an electron escape the substance. The first method is known as thermionic emission. As we all know, when we heat a substance, the heat energy is transferred or absorbed to its molecules or the particles, which gain energy and are further excited. When a metal is heated, its free electron gets sufficient thermal energy, which may be enough to overcome the surface barrier. Once this energy becomes enough or just enough to escape the surface barrier, the electron is removed or escapes from the surface. This phenomenon is known as thermionic emission. The next method is known as field emission or cold cathode emission. When a metal surface is subjected to a very high electric field, the electrons are emitted from it. The next process is known as photoelectric emission. In this process, electrons are emitted from metal surface when electromagnetic radiations of sufficiently high frequency are incident on them. The emitted electrons are also called photoelectrons, which will be studied in detail. Now let us see photoelectric effect in depth. The basic concept of photoelectric effect is that when light rays are made incident on a metal surface, it may knock out an electron from the metal surface if it carries certain threshold energy described as work function of that metal. This phenomenon can be explained by wave mechanics of light, which holds good for explaining concepts like interference, diffraction, polarization, etc. The phenomena like photoelectric effect, Compton effect, etc. require quantum theory of light, which assumes that light energy is distributed in packets, that is, at discrete intervals. You cannot expect to be getting 1.5 or 2.5 packets, but discrete intervals like 1, 2, 3, and so on. This is how Einstein was able to explain the concept of photoelectric effect and predict the results that he measured. This contradicts the assumption of light being a wave and led to many arguments, which were only settled by assuming dual nature of light. That is, the light behaves like a particle as well as like a wave, depending upon the type of experiment being conducted. While everyone focused on light's nature around 1920, Louis de Broglie had a very different vision. He said, hey, let's forget the light. What about the electron that pops out from the surface? Why can't the electron also have dual nature? So maybe what we think of particles isn't right. Maybe a particle is a particle and also a wave at times. He figured out the wavelength of the particle, if at all it had one. De Broglie postulated that lambda should be is equals to h upon p, where h is a Planck's constant which Planck figured out during the black bodies experiment, and its value is really very small, which is 6.626 multiplied by 10 raised to minus 34 joules second, where p is the momentum of the electron. If you look at the equation of the wavelength of the particle, you will fairly assume, since the photons have no mass, the momentum, which is mass times velocity, should always be equal to 0. So does it mean that the wavelength is infinite? No, it turns out it isn't actually true. The actual relationship between the energy and the speed is basically given by E square is equals to mass at rest square multiplied by speed raised to 4 plus momentum raised to square multiplied by c raised to square. And we also know that E is equals to Planck's constant multiplied by the frequency. Now, looking at the first equation, we can fairly assume that light has no rest mass, hence the first term has to be 0. Now substituting equation 1 and 2, we can see that h square f square is equals to p square c square. Now, taking off the roots, we can jumble up the equation and conclude that h upon p is equals to c upon f. Now, we all know the speed of the light is lambda multiplied by frequency. Hence, c upon f has to be equal to lambda. So maybe using this equation, de Broglie concluded that if electron has a wavelength, it has to be equal to h upon p. Now this was just a postulate, a hypothesis, which was concluded and confirmed only in 1927 when Davison and Gamow shot electrons through a double slit experiment. Now this double slit was specially created using an atomic structure which was able to carry such a narrow slit, and only to discover that de Broglie was true. The electrons did deviate once passing through the slit. Electrons, that are basically particles, were confirmed to have wave-like properties. Well, good job, de Broglie.